So with that, I'm gonna reserve basically the most of the remaining time, by which I mean maybe 30, 40 minutes. I don't want to make it too long. Basically, alpha testing, our custom GPT. I think I'm going to be updating it in about 2 weeks. And I've been actually, so maybe I can show this. What I've been working on in the past, whatever, couple weeks is basically to be ready in a couple weeks time to update the lecture summaries that the CoA physics GPT has access to. So for that, I need to clean up the transcripts, and I just finished this lecture 18, and I'm currently in the process of doing this. And I still need to do lectures 20 and 21. That's the next group of topics that will be coming up when we are done with electrostatics. So part of my process there is to basically take the automatic caption. Oops, let me not do that. Take the automatic captions, which are pretty close, but still have enough errors in it that it's not really where it should be, and clean it up, review it. And this is part where I do get help from ChatGPT, but again, I do review everything to make sure it has, if it's not verbatim, that it has correct meaning. So I finished the lecture 18. I'm currently working on lecture 19. Did I not save this? I might have forgotten to save it. It's okay. I was just doing one paragraph. I can go back and do that. I think I did forget to save something. So where I start is start with this, paste into ChatGPT. Anyway, so that's what I'm working on. I think I'm on pace to be able to add on the magnetostatics material when the time comes for you to have finished the electrostatics. I think this week you are doing Gauss's law. Next week you'll be doing voltages, capacitors, and then the week after that is when you are doing two things at the same time: electrostatics and timed assessments, and beginning the circuits material. So I think I'm on track to update all that material into CoA Physics GPT. And as I'm doing that update, I'll also update some of the other things that's come up in these sessions. That's really why I'm testing CoA Physics GPT in this session, because I think one main thing I will definitely make sure it's improved on is how it handles multi-part questions. With multi-part questions, it really shouldn't be trying all the parts all at once. It should be helping you with part A. Oops, did I forget to do this? Yeah, I forgot to clear this. Actually, no, I do actually have to do these. Let me do this kind of off screen, because I have to do this using my instructor access, giving test to student basically an exemption, excusal from this assignment, so that test to student doesn't need to do them to clear it. And I guess I didn't actually get to mention this, but I will mention it as I'm getting through clearing the module requirements. Just finish with this part. Excuse test student out of this. Okay, let me go back being test student, and it's excused, so it's cleared. I don't really have to use late pass. I can go to the next one. This one I actually don't have to see at all. There's no module requirement for this. And now this that module. Let me skip this. I don't need to deal with this to unlock the lecture module, so just keep clicking next until I get to the lecture module. So starting in week 3, you have much looser module requirements. So those of you who are working through the course materials, you've seen this already, but if any of you who are behind is watching this virtual class session, then this is what I want to highlight. there's a change of module structure. Mainly in the linear progression, the module requirements are a lot weaker. So within the module, so once you are in week 3, you can actually just skip to the problem set. Like you don't have to go through all the things in linear order. In fact, I'll do that right after this. So linear progression no longer enforced. Now the module requirement between the module prereqs are still enforced. Let's see. Yeah, prerequisites between modules are still enforced. But here's the thing. All the remaining module requirements are basically marked as done or view the page. So nothing really stops some of you from going all the way to the end of the semester because you don't have to do any real work to clear the module requirements. So for those of you who might still be stuck in weeks 1 and 2, this is what I'm highlighting and saying, get to week 3. Once you are in week 3, you get great deal of flexibility. I'm not saying that you shouldn't do the coursework, but if you fall behind, you are not in danger of getting locked out from the rest of the class because that's no longer an issue. So get to week 3 and then try to keep up as best as you can. So let me skip to the problem set 5 in the nearer the end of the week 3 material, and I can start it right away. I haven't done the lecture assignment, and all of that is fine because there's no linear completion requirement within the module itself. So let me actually test the CoA Physics GPT. I guess I'll start out with our usual test. Oh, this is a difficult question. Let me ask this. So I'm just gonna paste it in, and so it's testing two things at the same time. One, how does it handle it? Does it simply answer the thing, or does it check with me first? What have I tried, and help me with the next step. That's one thing I'm testing. And two, how does it handle it? It should set up the integration and all that. It probably does that. I think even earlier version of ChatGPT did that fine. So we will see. And unlike looking at this picture reminds me of there's a rotational inertia question in physics 4a. And for that question, you could have done it by superposition principle, looking up some formulas. Here, you can't unless you happen to know a place where you can just look up the answer again, which I don't recommend that you do. But there is not like a table of results that would have this particular setup in that table because it's frankly not all that common, not all that useful. Really, what's useful in dealing with this question is learning how to do this by direct integration. This is a classic. Now, it might be hallucinating lecture. Maybe. I don't know. I can't remember. Let me just double check to see if it's hallucinating a lecture. All of that. Yeah, it's definitely hallucinating a lecture. So, as I'm updating it to lecture because it's in lecture 10 or lecture 9, not lecture 7. There's an update to how I'm structuring the summaries that I'm hoping will limit its lecture hallucination problem. Because that's like lecture 7 covers something entirely different. So before I jump in, what have you tried so far? Okay. Now, it's asking that question. And then, is it doing the thing? Yeah, it's like, so I do need to strengthen its system instruction. So, it should have stopped after here and, wait for my answer to the question, not do this entire thing. So it says do this now, model as many little charges. Let me ask it this. I get what you are saying. Yeah, this is just copy and paste. Not handling the mathematical expressions well. along the x-axis. Um, or more precisely, I think I know what you are trying to say, but I'm having trouble doing the modeling. Can you draw a picture for me? And it used to be that ChatGPT couldn't really draw diagrams in an accurate way, but it's gotten a lot better. It's kind of a hit and miss, or hit or miss. This doing image generation makes me worry that it might do it incorrectly, but let me see. It usually seems to do better when it's doing this through like a graph generation. I might put something in the system instructions that has the GPT preferring that path over using DALL-E that generates an image. So let's give this a try. So I mean, in the homework help video, you see how I draw it. I have like things drawn so that this looks broken up. I pick some random midway point as my representative element, DQ. And yeah, I don't think this is doing that. Yeah, I mean, it kind of cut the rod in the middle and stopped drawing it. So yeah, I don't know if drawing that intermediate diagram correctly is something that it does well still. So let me not waste too much time on it. Yeah, this is a very bad drawing. Look at my homework help video, not this. I won't waste any more time on that. So let's say I'm trying to follow its instructions and kind of draw the drawing myself, which is actually what I do recommend that you do when you find that ChatGPT doesn't draw drawings all that well. But it usually gives a pretty good instruction, so you can be its eyes and hands. So model the rod as many little charges dq. So many little charges. Break it up. Dot dot dot. Dot dot dot, and just pick a spot. So this spot has the amount of charge dq, and it's saying let that be lambda dx, and the dx would be the size of the thing. Yeah, lambda is I guess given. Along the x-axis from x equals 0 to x equals L, let the point P sit on this axis at, so I think it's implicitly defining x equals 0 here, and P is at L plus A. For an element at position x, so this would be an element at position x, separation P, R, okay, so that would be this picture, R is equal to wait, I'm pretty sure that's wrong. Let me look at the limits of integration. I mean, it might end up with a correct answer. So I will let me do the correction in red. So this expression can be considered to be correct if you actually define the axis this way. So this is actually your x equals 0, and x is positive going that way. Then R equals a plus x actually works. Let me follow it that way and see if we still end up with the correct answer. Coulomb's law, dE, so let me write that down. Well, I'll continue the red pen. Directional field at P. Well, I guess direction actually doesn't matter. I mean, direction ends up being that way. I'll just say call that x hat, even though that's kind of opposite of how the coordinate x is going. So dE is equal to ke amount of charge, and it's the field version, so we don't need the test charge, divided by r squared, and we are using this r is equal to ke lambda dx over a plus x squared. Yeah, integrating this along the rod, do that. Oh. So I think it asks what do you get when you carry out the integral. So let me do that. I guess I'll say I did the integral in O from alpha, and let me actually do it in O from alpha. This writing's in the way, but I'll just type it out, move it, and take a screenshot and do all that. So I only have to handle the integral part, so I still integrate 1 over a plus x squared from x equals, wait, was it actually 0 to L? Oh, must be coming up often enough that that's what people ask. So let me put this here for yeah, and these are all conditions that's probably met in our situation, so that looks right. O from alpha, so is the result, oh, I can't remember, L divided by A times A plus L is the result. L divided by A times A plus L. It'll probably say yes, and then it's gonna continue on, and then just give me the answer. Yeah, so the answer that Wolfram alpha gives is from combining the two fractions together. Simplify, quick self-check. Yeah, so it's doing way too much in the first response. I do need to kind of correct that. Integral is right. Yeah, multiply. Yeah. So a quick check the limit. So I'll do k. By the way, if you are not sure between ke and k, so this is one tip about using MyOpenMath. All the variables that may be used in evaluating an algebraic question, it's under bars. So okay, if it's k, then it's k times lambda, and then I think k times lambda, and then the integral. Yeah, so the integral was that L A times A plus L. So that should be graded as correct, and I'll just ask ChatGPT about one thing. So I'll do it this way. Okay, I got the right answer, but I have something to check with you. When I set point P at a distance of L plus R from x equals 0 point, it didn't really work out. At least my drawing didn't make sense to me. I had to move x equals 0 to the right end of the rod at distance A from the point P. Can you help me understand this? So what ChatGPT should say is that it made a mistake. I mean, mistake that doesn't end up affecting the final answer, but it's still a mistake nonetheless. I don't know if it's gonna recognize that, or if it'll just hallucinate. Great question. Consistent with your coordinates? Yeah, you can put it any. So that's why I was checking the limits of integration. With the x equals 0 here, yeah. So it's expression for r and the and the limits of integration. Yeah, to clean setups, originate the right end of what you ended up using. Yeah, and that's actually what it like this expression that ChatGPT gave. Origin. Oh wait. I guess. Wait, did I misread it earlier? Maybe. Oh, you know what? I did misread it when it said no. It's, PC tone. Yeah. I didn't misread it. Yeah, that. And then it said this. Yeah, they were contradicting each other. Yeah, good. Okay. So distance to p. Yeah. So this is what it claimed it was, and no, and then distance to p. Yeah, then would be this. Yeah. L plus a minus x. Yeah, and then x can. I guess it can still go from 0 to L. Yeah, and the final result should end up being the same. Drawing something go sideways. Yeah, so I mean, this explanation here is right enough. It's not admitting to having made a mistake earlier, but that's fine. I don't know. That might be too much of a too far back of a context for me to expect a CoA physics GPT to go back to. Let me find another question that maybe is more of an application of Gauss's law question. Not this question. There might be a. I'm looking for. Sometimes there's a question where charge is at a corner of a cube. That can be interesting to answer, but I guess I don't have that. Not
I
even
think
sure.
that was in the last one, problem set 4, the corner charges.
Corner? No, because it will be asking about flux. I'm
Oh,
looking.
okay.
Yeah. I mean, let me see if that's in this set at all. It might be just the test student's luck of not getting that question, but maybe I'm misremembering. Let's see. It should be quick to just click next to through. There's a figure that goes with it, so it's a pretty quick thing to. Yeah, it's this question. So let's see. This is part of the question. So you could get it at 6 or 7. So let me actually roll the dice a little bit to get that. So let me do this. So yeah. So let me just roll the dice here. Get a similar question. Another similar question. Okay, that one. So let's see. I want to do below question which can simply rather simpler than brute force alternative. And let's say I've read the Gauss's law, I understand some of it, and I need to kind of maybe zoom out a little bit. It's getting really tiny, but I think it's still readable mostly. Yeah, let me keep it here so that I don't have to scroll in between. And I can just keep it here. So let's say I do part A fine. I remember enough of Gauss's law. So point Q located at the center of a cube whose signs are of length L. No other charges in this system. What is the electric flux through one face of the cube? So you do the Gauss's law. The electric flux through the entire cube, E dot dA, is equal to the charge enclosed divided by epsilon naught. Or if we are using my other approach that I started doing after a feedback from one of my colleagues, basically continuing to use Coulomb's constant through the end of the entire semester, and later on this will pay off. So electric flux through one phase, so you realize, oh, there are 6 phases. So you do the Q enclosed divided by epsilon naught. You could type it out like epsilon naught, or you find it from vars. and then you also divide it by 6 because of 6 faces. Let's say you do that, you submit it, it should say that's correct, and then you make a mistake as you are doing this. You see the cube at the corner and you think, it's still inside the cube, so my answer shouldn't change. So you look at you put in the same answer, and then it says it's wrong. Let's see if ChatGPT will explain that, or CoA Physics GPT. So let me continue the previous conversation. I think let me move on to a new question. I thought I understood the whole point of Gauss's law. Flux doesn't change when you move the charge inside the volume, but the system says my answer to part B is wrong. Can you help me understand? And I think even if this charge had been within the cube, the flux through that surface would have changed. Like in A, you could do division by 6 because the charge was at the center of the cube. So you could make a symmetry argument that all 6 faces have the same flux and all that. Once the charge is not at the center, you can't make that argument anymore. So you still know the total flux through all the surfaces, but some faces might have greater flux. And this charge is actually tricky because it's not technically inside the cube anymore, only like is it an eighth or a quarter? So 1, 2, 3, 4. Yeah, only an eighth of the charge effectively is still inside the cube. So even if you are calculating flux through all 6 surfaces of this cube, it actually wouldn't be the same Q over epsilon naught. It'll be like Q over 8 epsilon naught. So. And then I think, if you do it that way, you might actually be, so the correct answer is a Q over 24 epsilon naught, I think. And I think you can get it through basically arguing that that surface and the top and the right surface are kind of symmetrically distributed, so they should all be splitting the flux evenly. And the 3 surfaces that are touching this charge, the electric field is parallel, they have 0 flux. I think you could do it that way. But the standard argument that you will see me use in homework help video is basically imagining this to be inside a larger cube of side 2a. And this is an eighth of that. Classic corner charge symmetry trap from. That's interesting. I think that's the correct lecture number. I think. Let me just double check. So it might, I don't know, sometimes it hallucinates lectures, sometimes it doesn't. Yeah, I don't think it's, I'm not entirely sure if that particular example is in this lecture. Probably isn't. Yeah, I don't think that example is in this lecture, so it might still be hallucinating that this is, this is not in this lecture. First, what did you try for B? It looks like you reused the part A idea. That only, at the center, charge at the corner, the 6 faces are not equivalent. Okay. So, that's. It's just giving me the answer. I got the answer. Let me put it in and. But can you help me visualize 8 identical small cubes? I'm not sure what you mean by that. And it really shouldn't have given you the answer. Again, I'm gonna try to strengthen the system instruction so that it kind of works. It's more interactive as it works with you to get to that. And you should always be able to bypass it by saying, "I want the answer right now," through a tantrum, and it'll do what you want it to do. Like stopping that is not possible, I think, through system instructions. So, but it should attempt at being more interactive first. Now the figure that it's drawing, is that gonna be correct? I want to see. Certain diagrams it was doing fine, but I think it's just diagrams are probably it's a weaker point where so in the kind of questions where it wouldn't make a mistake simply it describe things verbally in words when it's doing that. Yeah, I think it's just copying that. It's not it's not doing the 8 identical small cubes. So that's just the same cube that we had earlier. It's not smaller or 8. Let me not waste too much time. Yes, please. Yeah, draw. Might still mess it up. We'll see. As it's doing that, I want to think through one other question to ask. The other question to ask is, so this is one approach. Let me paint the picture of the other approach I was describing with one mistake that I forget that this charge is only like a portion of this charge is in this small cube. May take a moment. Let me start to just type it out. So think. Yeah, it's still not correct because the charge should be drawn to be at the center over there. But best they can do. Thank you. I think I get it better. One other question related to this setup. I think I understand your argument involving AQs, but I got a different answer earlier, thinking about how the flux through each of the faces is different because the charge is not at the center anymore. And the argument I came up with gave me Q divided by 3 epsilon naught because the shaded face along with the other two faces not touching the charge seemed symmetrically positioned. So once I get the total flux Q over epsilon naught, that is the mistake that I'm making. Epsilon naught, that is the mistake I'm making. Total flux, I can divide it into 3 because the other 3 faces touching the charge should have no flux going through them. All electric field lines are in the plane of each of those other 3 faces. Why doesn't this approach work? I wonder how it'll explain it. After this, I think I can probably ask you one more question, one more, let's say, normal Gauss's law application question. maybe one of the later questions that have like a density changing as a function of distance. It'll always tell you something positive. It seems stuck. I'm gonna go open another window. Oh wait, I actually should have done it this way. At least this seemed to fix it last time. Yeah. Great reasoning, but you are almost took effect. The touch the. Do we have zero flux? Yeah, good. I was right. And yeah, correct. But the total flux through the small cube is not that. Yeah, enclose the charge on the surface. Yeah, it does not include the whole charge. Yeah, and it's a kind of like what if it's a point charge? So it could be right inside the corner. It's the kind of thing. I think anytime you have that kind of singularity, if you do the reasonable thing, don't make it a point charge, make it a small but not quite point, and kind of assume that it's an eighth of the corner, so only an eighth of the charge is there, then it ends up working out. Yeah. So yeah, that gives the correct answer still. Yeah. It's the kind of thing I think. This is the kind of thing that makes us physicists lazy, in that things work out if we assume things are behaving nicely. Like instead of this charge being a real, actual, like a Dirac delta function, point charge that's kind of slightly inside, the kind of the result you would get is the result that would be correct if things are kind of smoothed out, not things behaving pathologically, and it just works. So all right, so let me not waste any time so that I can maybe spend 5 minutes on a normal-ish looking question. So let's see. Thought I was looking at one of the later questions. That feels like that's gonna take long. This is a little bit shorter, I think. Let me look at question 10. So this should be 0, this should be... Oh, let me give it a try. So this is, again, Gauss's law application question. But let me imagine someone doing this. You can go formula hunting and find just the right formulas that will give you the right answer. Maybe you locked on answering this as 0 and you just got it right without fully understanding why it's 0. And for the other question, you use the Coulomb's law for point charge. You just looked up this formula somewhere, you're just plugging numbers into random formulas, and it ended up giving you correct answer. So r squared, and let me do this in Wolfram alpha just to save a little bit of time. KE. Wonder if Wolfram alpha will understand that. It might not for mu c. I think it'll understand that. Let's see. I'm pretty sure it actually understands this. This notation, it bothers me because mu is not u, but I think it's common enough that Wolfram alpha actually understands it. And then 10 centimeters squared. Let's see. Oh yeah, it didn't understand that. Might do it with underscore, that it's a Coulomb constant. Yeah, Coulomb constant. Yeah, the UC. So again, this bothers me, but it knows what you meant. So you get Newton per Coulomb. So 3.595. So 3.595 is 6 Newton per Coulomb. And let me just put this here. Oops, oh, that's the wrong Wolfram alpha. Is the correct Wolfram alpha? Yeah, so I'll say I got the correct answer, but I feel like I missed something. A new question. This one I did it on my own and I got the correct answer, but I feel like I missed something because it's question 10, so I thought there should be more involved. I feel like my instructor's going to ask some follow-up question at the required one-on-one meeting that I can't answer, and I probably will. Or skip this question and ask you other questions that I can answer. Can you help me prep here? And it should help you understand the charges on a conductor, that it's like spherical shell distribution, and how to use Gauss's law arguments in that distribution to argue that electric field is zero anywhere inside the spherical shell, and that with this one you can go either way. You could either do the proper thing and do application of Gauss's law, or appeal to application of Gauss's law to say spherical symmetric distribution gives you same electric field as an electric field of point charge, as long as you are looking at outside the sphere. Yeah, I'm pretty sure that lecture 12 is again hallucinated. So this screen is updating, but not quickly enough. Let me do it here. I don't know. Something is kind of hanging up the JavaScript or whatever. Okay, new question. Follow-up checklist. Oh, let's see. If those are the questions that I would ask. Make sure two answers correct. Inside the conductor, yeah, equals 0. Oh yeah, I guess you could appeal to the conductor property too. Yeah, sure. Outside the charge conducting sphere, yeah, symmetry. Field is radial, depends only on R. So yeah, it's actually showing the kind of steps of Gauss's law application, which is what you should have done rather than look up a random formula. Yeah. Common follow-ups, surface charge. Yeah, I wouldn't be asking you that. At least not for the second track meeting, because the point of any follow-up question, if any, is to make sure you are doing it properly, not accidentally getting the question right. I wouldn't ask you to give me new information that's not part of the question. So, yeah, this also no. That's next week's material. It's not guessing correctly. So I think I do have to give CoA Physics GPT more information about what kind of questions I typically ask. So yeah. I mean, this is more about lack of information I've provided the CoA Physics GPT, because it doesn't know. Yeah, so my instructor says that these aren't the kind of questions he would ask, because these all bring new information that's not part of the original question. It says that here the only ask questions that makes sure that I didn't get the question accidentally right. I'm writing this more as a note to myself, so that I will remember to address this point when I'm updating the system instructions for CoA Physics GPT. Yeah, so I think that's probably everything. Let me just read its response. There shouldn't be anything new or different. And by the way, your conversations, it doesn't really get saved anywhere. I will tell you, I don't have access to it. Like I have access to this chat because it's my account. But anyone else's chats, even though you are using my custom GPT, I don't have access to those chats. It's not something that I have access to. And I think on the flip side also the kind of the your conversation content, I don't think it actually affects how this GPT interacts with other people. It's so like what I do here, it doesn't actually change CoA Physics GPT. To change CoA Physics GPT, I have to change its system instructions, maybe its knowledge base. So this is more note for myself, so that I remember to play with the different system instructions that will help address this point. Yeah. So like this is one of the questions I might ask to and make sure that you didn't just randomly guess zero that happened to be correct. Why can we use? Yeah. That actually is the question I would ask. I don't know if I would ask that. It's kind of too detailed. Right, why not use, because it's like at distance of 7 centimeters 10 minus 3 from the sphere, y10 you measure from center. Yeah, I might ask this. That's actually a good question. But second track meeting, I don't do a lot of follow-up questions. I only do follow-up questions under maybe two circumstances. One, there's either no work or whatever work you have doesn't really match up with the work I expect to see. I expect to see Gauss's law application here, not random version of Coulomb's law. Two, sometimes in the as the meeting progresses, I get a feeling that you just memorized a bunch of solutions. Then I might deliberately ask you some questions to take you outside of that memorized solution. Otherwise, in the second track meeting, it's not my goal to ask a bunch of follow-up questions, because really the second track is for people who get nervous about the follow-up questions. Yeah, the first few look good. Sometimes GPT does this like a bunch of lists. It usually gets the core things in the first few. The rest, it's just throwing everything at the wall. So, all right. So I think that covers everything. Unless testing of CoA Physics GPT to get some ideas on what I need to improve next time I update it in about like 2 weeks or so. I think that's the schedule I need to keep. I think that's everything. Again, thank you so much to those of you joining here in real time. Those of you who may be joining by recorded video, let me say goodbye to people joining by recorded video, by which I'm going to stop the recording, and then I'll stay online briefly in case people who are here in real time had any questions. So bye to people joining by recorded video.